Welcome to part two of our class notes for eclipses. This part two, is going to cover lunar eclipses. It's going to be even shorter than solar eclipses. It's going to kind of follow the same format there as you see on the doc of watching a video and answering some questions. I'll go through and do a little bit of summary at the end to make sure that you're not missing any of the important information. But now you've done an ed puzzle. You're going to do this video and these notes. Hopefully, you'll want to do the optional section as well. I think that's pretty much going to be able to hit everything that you need to know and understand about eclipses. So let's go ahead and take a look at the Google slide presentation. All right, so if this was a solar eclipse, now pay attention to the positioning here. Now let's take a look at the lunar eclipse. Okay, and the lunar eclipse, notice where the moon is now positioned. Instead of being here, it's over here. So in a lunar eclipse, it's the sun, then the earth, then the moon. That's what creates the lunar eclipse. We get this shadow that's cast from earth onto the moon, blocking the light of the moon. Okay? Like it said in the video, all the way back to your ed puzzle, and it'll explain a little bit in the next one, is that if you notice this positioning, this is the same exact position that the sun, the earth, and moon are in for a full moon. And we should know that we don't have a lunar eclipse every time there's a full moon. Just like in a solar eclipse, when the sun is over here during the new moon phase, we don't have a solar eclipse every time that there is a new moon. And that's just because that even though this is two-dimensional here, you have to remember that the moon is not traveling on a straight plane as it goes through and revolves around the earth. Okay, so it is tilted. And so because of that, there's only certain times when all three line up along the same plane where the shadows are actually going to be cast onto the other object. So whether it's the moon casting and blocking the sun, or the earth blocking the light to the moon for a lunar eclipse. So let's go ahead and take a look at a lunar eclipse.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
Right, so I know that video was also pretty quick as they went through and talked about the lunar eclipse, but I thought the graphics were really helpful in understanding why we see the moon, and also give a little bit of an explanation there in case you weren't sure of why we get this red color for the moon. Okay, sometimes we call those blood moons, right? So that's why we get that red color. It's also why we see some of those red and oranges at sunrise and at sunset. It has to do with the light rays on the visible light spectrum, and how some of them pass through the atmosphere and some of them kind of bounce back. So you only are seeing certain colors as it comes through the horizon, as the sun comes through the horizon. All right, underneath lunar eclipse, the two terms that you heard a bunch in all of the videos that we watched, even back to your ed puzzle, umbra and penumbra. Okay? Using everything that we have watched I want you to come up with your own definitions for umbra and penumbra. And I'm going to give you a challenge. I'm going to call them a 5-word definition. So the challenge is, can you define you define the word umbra in 5 words or less, and penumbra in 5 words or less? Right, now it's not a competition to see if you can do it in less words. Okay, it still needs to make sense to you for it to understand. But this way, you're kind of crafting your own definition instead of just getting a definition off of a book or off of the video or Googling the definition, so that it's more your own and you have some ownership of it, okay? All right, so take a moment and do that now, and then unpause the video and come back and we'll kind of close things up. Now we've gone through both solar and lunar eclipses. You should have typed in definitions for umbra and penumbra in 5 words or less. Only thing that's left is the optional work that's beneath there. If that's something that you choose to do on eclipses, I don't think it's very difficult. I don't think it's going to take you very long, especially if you've been really focused in watching the videos and listening to what was being not only described for you, but also the graphics, because that's the easiest way to understand eclipses, is understanding the graphics and the placement of the Earth, the Sun, and the Moon. And then underneath that, remember, if you wanted to, go through and do some of the extra credit, that's there too. All right, so you have those options for you as you finish up your eclipses. All right, that's it for this, and for your class notes for eclipses, there'll be another video about tides later in the week.